So for this video, I will be looking at linear independence and some examples of linear independence. So we have some definitions here. Linear dependence. The vector x is said to be linearly dependent on the vectors x1, x2 up to xn if it can be written as a linear combination of them. And linear independence. A set of vectors is said to be linearly independent if no one member of the set is linearly dependent on the others in the set. So on to our first example. We have the vectors x1, x2, x3 are linearly independent in V, where V is a real vector space. Prove that x1 plus x2, x1 plus x3, and x2 plus x3 are linearly independent. So let's go ahead and write out what we know. So we say for some k1, k2, k3 in R, our zero vector is equal to k1 x1 plus k2 x2 plus k3 x3, and this is what is known since so we have k1 is equal to k2 is equal to k3 since our x1, x2 and x3 are linearly independent. So let's say for some a, b and c in R, there exists a vector such that a x1 plus x2 plus b x1 plus x3 and c times x2 plus x3, and our vector x is equal to, if we expand this, we see that we have ax1 plus ax2 plus bx1 plus bx2 plus cx2 plus cx3. Now simplifying this, we have a plus bx1 plus a plus cx2 plus b plus cx3. If we notice our x1, x2 and x3 were given as being linearly independent, which implies that our a plus b is equal to 0, our a plus c is also equal to 0, and our b plus c is equal to 0. So if we write this out in matrix form, we have 1 1 0 1 0 1 0 1 1. And if we take the determinant of this matrix, so taking determinant of the matrix 1 1 0 1 0 1 0 1 1, we see that determinant is equal to -2 and not 0. So if our determinant was equal to 0, then it would imply that our vectors are linearly dependent. So now for example 2, we have show that the functions 1 sine squared x, cos squared x are linearly dependent in the continuous vector space. So recall our identity of sine squared x plus cos squared x is equal to 1. So if you say some vector x can be written linearly such that a1 plus b sine squared x plus c cos squared x for a, b, and c in R. Now, if we notice that one vector can be written in terms of another if our vector is equal to minus 1, 1, and 1. So if our vector is equal to minus 1, 1, and 1, it implies that a is equal to minus 1, b is equal to 1, and c is equal to 1. So we have minus 1 plus sine squared x plus cos squared x, which implies that our 1 is equal to sine squared x plus cos squared x. So 1 sine x cos squared x can be written as a linear combination of the vectors minus 1, 1, and 1. So, and hence the functions are dependent.